This video will go through the answers to exercise sheet number 1 on naming organic compounds. Here's our first one. We start by identifying the homologous series, and the OH hydroxyl group tells us it's an alcohol. It's only got a single carbon, so its prefix will be meth, and the suffix for the alcohols is -anol. So methanol is the name of that compound. Alright, so there's our functional group. It's a carbonyl group on the end of a chain, and so that tells us it's an aldehyde. There's only one carbon, and so its prefix is meth, and the aldehydes have a suffix of -anol, and so that's methanol. There's our functional group for this compound, C double bond O, that's a carbonyl group. OH is the hydroxyl group, and together they make up what we know as the carboxyl group, which is characteristics of the carboxylic acids. It's just a single carbon, and so its prefix is meth, and anoic acid is the suffix for the carboxylic acids. So methanoic acid is the name of that one. Alright, they've now given us a condensed structural formula. I think it's very difficult to name directly from a condensed structural formula, so my suggestion would always be that you draw out the full displayed structural formula first. So let's start from the left. CH3, there's C with 3 bonds coming out. I haven't put in the hydrogens because I'm not answering a question, I'm just having a look at the structure. So there's CH3. The next carbon has only got a single oxygen before another carbon, which means that it must be double bonded to the oxygen, and so there's our carbonyl group, then CH2 and CH3. And so our functional group then is the carbonyl group, characteristic of a ketone. It's on carbon number 2, and so we would have bute for the 4 carbons, and the ketone group is on carbon number 2, so butane 2-one. But if you look carefully, you'll see the carbonyl group cannot be on carbon number 3, because then we would just number from the right, and it would be back on carbon number 2. And it can't be on a terminal carbon, because then it would be an aldehyde. So actually we can just call it butanone. Alright, the bottom one. Again, let's draw it out. CHO means that the terminal carbon must be double bonded to an oxygen and a single hydrogen. And that, of course, is the aldehyde functional group. Then a CH2, CH2, and a CH3. So there's our carbonyl group on the end of a chain, making it an aldehyde. We've got 4 carbons, and so it would be bute for the 4 carbons and anol for the aldehyde functional group. So butanol. Alright, another condensed structural formula, so let's go ahead and draw it out. CH3, there we have it. CH2, 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 and then COOH, that's a carboxyl group. So it's a C double bonded to an oxygen and single bonded to an oxygen and then to a hydrogen. So there's our carboxyl functional group of the carboxylic acids. If we number the carbons, we get 5 of them. So the prefix would be pent, and the suffix is anoic acid. So pentanoic acid is the name of that compound. Right, last one is an ester. There's the ester functional group. The branch on the far side of the oxygen in the chain has got 2 carbons. I've labelled them 1 and 2 there, so that means it's an ethyl branch. Then the carbon that holds the 2 oxygens, if I number that one, number 1, there we go, that's then bonded to a CH2 group, but there are 2 of them. So that means that carbons 2 and 3 would be there, and then the CH3 on the end is carbon number 4. So we've got 4 carbons, so it's bute, and the suffix for the esters is anoate, so that compound's ethyl butanoate.